All right, I'm going to talk about how to interpret a coefficient in a linear regression model. And I'm going to try to do it quickly because I think this is the kind of video that you might want to come back to and watch over again when the time comes that you need it. So let's just put a model up on the screen. Let's say that we have a data set of people who founded their own companies, and we see how big those companies are, and we want to try to see what predicts the size of the companies that they founded. So we have firm size regressed on years of education that person has, the logarithm of their parents' education, whether they are male or not, whether they have a college degree or not, whether they have if they have a high school degree but no college degree, and those are our predictors in this model. So let's say we are particularly interested right now in the coefficient B1 or beta 1 on the years of education. And how do we interpret this coefficient? And every regression coefficient, pretty much a 1 unit change in the variable that is the predictor is associated with a coefficient size unit change in the outcome variable, controlling for all the other variables in the model. Take that sentence and memorize it and fill in the blanks with whatever is relevant in your particular regression, because that is pretty much always going to be the answer with very few exceptions. So in this case, a 1 unit increase in years of education, controlling for all the other variables in the model. So comparing two different people with one unit difference in years of education, but the same parental education, the same gender, the same college degree, high school degree, etc. The person with 1 more year of education will on average have a firm size that is beta 1 larger. A 1 unit increase in years of education is associated with a beta 1 increase in firm size. Okay, so that's the main thing, right? That's what you need to come back to. Everything else is detail, but let's get into some of those details. So I mentioned you have to keep in mind what you're controlling for. You have to interpret each coefficient in terms of what you are controlling for. So the relationship that we're seeing between years of education and firm size is controlling for all the other stuff in the model. You have to think carefully about what does it mean for all this other stuff to be controlled for. We've removed all the variation in years of education that is explained by all this other stuff. Right? So we are saying a 1 unit year increase in years of education, controlling for parental education, right? Controlling for your gender, and controlling for college degree and high school degree. So we have to think about, well, what does it mean for years of education to increase by 1 unit when we're controlling for all this stuff? And sometimes it can get kind of weird. What does it mean to say that years of education is increased by 1 year when we're controlling for having a high school degree or a college degree? Right? That's kind of strange. Well, that's thinking, okay, well, if they're not getting another degree from it, what's the increase in 1 year of education, right? So going from 10th grade to 11th grade, but not going from 11th grade to graduating with a high school degree, right? That's the sort of interpretation that has to come out because we're controlling for whether they have a degree or not. The second thing we have to think about, is this a causal effect or not? Just because we've written out a regression and thought of some interesting predictors and control variables doesn't mean that we have identified a causal effect. And most of the time, unless we've really, really, really carefully gone through it, we have not. And so we have to think, are there other things that have been left out of the model that might cause omitted variable bias? And the easiest way to think about it is, are there things that are not in the model that are predictors both of the variable that we're interested in and the outcome variable? And almost certainly there's some stuff that you can already think of in this model that predicts both years of education and the size of somebody's firm that they have founded. So this is probably not a causally identified model, which means that the beta 1 that we have is associational. That's why when I described it, I said a 1 unit increase in years of education is associated with a beta 1 increase in firm size, controlling for all this other stuff. I did not say that a 1 unit increase in years of education causes firm size to increase or leads firm size to increase by beta 1, because we don't know that. We have not yet answered the question of what the causal effect is. We just have a conditional association. By conditional, I mean we've controlled for all that other stuff. So conditional on the values of those other variables, we see a 1 unit increase in years of education. Third thing to keep in mind in terms of detail is the scale of the variables. To get any meaning out of these, you have to think about how big is a 1 unit change? How big is a beta 1 change? It's very common for me to see students look at a number like, okay, my beta 1 is 0.001. That must be a small effect. But, if the variable that you're looking at, if a 1 unit change is very, very tiny, then yet it makes sense that your coefficient would be very tiny because it's reflecting the effect of a 1 unit change. So beta 1 is the effect of a 1 unit change of years of education. That is a reasonably sized effect. We might be interested in, okay, what's the effect of 1 year of increase? And it has a beta 1 effect on firm size. Is that big or small? Well, to know that, you have to know what the scale of firm size is, which I haven't told you at all. Let's say that beta 1 is 0.05, okay? So a 1 unit increase in years of education increases firm size by 0.05. That means very different things if firm size is number of dollars of market capitalization, in which case 0.05 is like 5 cents and nothing. Or it could be that firm size is billions of dollars, in which case 0.05 is many millions of dollars, and that's a pretty big effect, right? So you have to know the scale of your variables to be able to interpret what a 1 unit change means and also what a coefficient sized change is. After that, what if the variable is binary? If the variable is binary, then that changes how we interpret the coefficient, except that it actually doesn't, right? We've been talking about the effect of a 1 unit change, and binary variables do 1 unit changes. They only do 1 unit changes. They go from 0 to 1 and perhaps back again. So let's look at male, for example. Male is a 0, 1 variable in this model. It's either 0 and you're not male, or it's 1 and you are male. So the coefficient beta 3 tells us what is our prediction. What is the going from non-male to male is associated with a beta 3 change in firm size, right? That is what we're doing. We're comparing male to non-male. That's what you get with a binary variable. You are comparing 1 to 0. So if beta 3 was, let's say, -1, that would mean that a male-founded firm has a firm size that is on average 1 less than a female or non-male-founded firm. In addition, we have categorical variables where there are binary variables, but they're all sort of part of a category. So we have a categorical set of variables here. We have college degree, high school degree, and presumably some other category that's been left out, maybe no high school degree. Right? In that case, it's the same idea. These are still binary variables. We're still doing 0 to 1 comparisons. The only thing is that it's always the 0 represents the excluded category. So if we have college degree, high school degree, and no high school degree, then the coefficient on college degree, the beta 4, is comparing the firm size of people with college degrees against the firm size of people founded by people without college degrees. So we're always comparing to the reference category, which means that those coefficients are entirely sensitive to what the reference category is. So here we've chosen to leave out people without high school degrees. They're still in the data, they just don't get their own coefficient because they are the reference. Everything is relative to them. If we had instead chosen to leave out college degree, well, the coefficient beta 5 would completely flip, because instead of being the high school degree people being compared to non-high school degree people, they're now being compared to college degree people, right? Which completely changes the interpretation of that coefficient. So with a categorical variable, it's comparing that category to the reference category, whatever that reference category happens to be. Thing to consider on the detail side is if the variable is transformed. I'm not going to go into the interpretation of all different kinds of transformations here, but all you have to do, let's say we're looking at log parental education here, is think, okay, we are still looking at a 1 unit change. It's just the 1 unit change of this variable. A 1 unit change in log of parental education is associated with a beta 2 change in firm size. But now we have to be careful. What does a 1 unit change in log of parental education mean in terms of parental education? I'm not going to go into the exact interpretations of that, but that's the sort of step that you need to make, right? You always think first of a 1 unit change in the whole variable, and then take the step of asking what that means in terms of the actual variable that you're interested in, parental education. Similar idea if you have polynomials. If you have multiple terms that represent the same variable, then you want to take maybe a derivative first to figure it out. I'm not going to go into detail on that. And I'm going to have another video on interaction terms if you have those as well. All right, that is it. That's the basics of how you can interpret a coefficient in a linear regression model. There are, of course, many details that I left out, but those are the main things that you need to consider when you look at this. And as always, it's really just the main thing is a 1 unit change in this thing is associated with a coefficient-sized change in the outcome variable. Everything else is detail. And so you just need to figure out what details apply in your particular scenario and apply them. Thank you.